Well, everybody, Happy New Year. Hope this New Year is going to be good to everybody. Well, I figured I'd start off by doing another power supply test video. This video, I'm going to test a Astron RS-35M, a linear power supply. I was just happened to be on the way home, so I decided to stop at my favorite electronics store. And lo and behold, I saw this used power supply. And I said, well, it's got to come home with me. So I'm a big fan of Astron power supplies. I've got a couple of 50 amp power supplies. I got the RS-50M. I've had that one since 1990, and it's been virtually in continuous use ever since. Currently, it's powering 4 or 5 transceivers over here. We've got an ICOM 2000, a 7300, a 9700, 7610, and a 706 Mark II-G. They're all powered off that one power supply. And I've not had a single problem with it. So I've been a big fan of it. I've also got a rack mount version of it as well. And then I've got kind of a beat up, little rusty 12 amp Astron that I use for smaller stuff. But I saw this, couldn't pass it up. It was a very good bargain. So anyway, I brought it home and I decided, well, let's see how well it works. So we got the supply there. I've got it hooked up to the electronic load. And we're going to use the HP 3400A to measure the ripple and noise. I'm going to use this scope that I got here a while back. It's an HP 1980B. I've got a whole backstory on this scope. I did a couple of videos where I had to repair the circuit that sets the sweep length for the readouts. It wasn't working right, but it's been working fine now. And then we're going to measure the load regulation percentage with this HP 3455A. Good old voltmeter. This thing was probably made in '79, and it was way ahead of its time back then. So let me get everything ready to go, and we'll knock her out. Okay, well, the first thing we're going to do is we're going to check for power supply rail noise with nothing but the load connected. So take the meter here, and I've got no load engaged at all. Inputs off. Power supply is at nominal operating voltage. So we're going to take our meter here, and this is looking pretty good. There's about 300 and 350 microvolts of just stray noise. I peaked up there to 400 microvolts. Not bad for a power supply. Now I got it like this because if I start hooking up other instruments like the meter and the scope, they're going to get some coupling on the cables there, and it'll just get conducted onto the power supply rails. So other than just the electronic load connected, that is looking pretty good. So now let's put that back up here, and let's engage a load. Let's try, let's just go for it. Let's go, according to the manual, it's designed to do 25 amps continuous, and it should have no more than 5 millivolts of ripple. So we will it's already set for 25 amps, so let's turn it on. Okay, we're okay there. We're showing about 25 amps there, so now let's check our ripple now. And it's jumped up a bit. We're almost just Just peaking a little above 600 microvolts. That is pretty damn good. That's you know, a little over half a millivolt. Not bad. Not bad at all. That's pretty good. Definitely well within spec. So now when we let's turn this off here. So now when we start adding leads, we're going to see the noise increase, but we should still see less than 5 millivolts of ripple the noise when we really load it down with everything attached. So we'll hook up the voltmeter next, and we'll check load regulation. Alrighty, next we're going to measure line regulation. So we're going to use this meter here, of course, and right now it's running just a smidge high, but that's okay, it's close enough. It should be within 50 millivolts, but you know, that'll work. So what we're going to do is we're going to use the math function on this, and we're going to set it up to report the percentage of error. So what we're going to do is we're going to set this instrument up. We're going to store our current voltage reading in both registers Y and Z. We're going to go to the math function for percentage. And right now we're just hovering right there at 0%. So, next thing we'll do is we're going to set our electronic load. Let's start with 5 amps. And turn that on. And we have a load regulation of 0.092%. Not bad. Certainly well within the 0.5% that it calls for in the service manual. So let's go to 10 amps. And load regulation is at 0.18%. So let's bump her up to 25 amps. Yep, just within 0.448%. Not bad. So hey, let's go to the max for real quick. Let's go to 35 amps. And we're just breaking over the load regulation limit, so not bad. I don't want to go any higher than that because the overcurrent protection circuits will kick in. Not bad. Okay, well, let's try transient response, and we'll use the scope for that. Okie dokie. The last test I'm going to do is transient response test. So what we'll do is that we're going to set our load here for a constant current of 17.5 amps, which is half of what the power supply is supposed to be able to produce. And our transient level is going to be set for 35 amps. And the frequency of the transients are going to be 1 kilohertz with a 50% duty cycle. So what this will do is that when I engage the load, it will pull 17.5 amps constantly, and then pulse to 35 amps at 1 kilohertz. So we will turn the load on, and we're pulling 17.5 amps. I don't see any noise or ripple error at all. So now let's turn the transient function on. And yes, we are seeing, we have 100 millivolts per division, so we are seeing 200 millivolts, positive and negative, so that's 400 millivolts peak to peak. And recovery time, let's see here if I got this set up correctly here. Let's try this. Oh yeah. So the pulse recovery time on the release side of the pulse, let's see what we got here. 10 microseconds, we got 10, 20, 30, a good 40 microseconds for the power supply voltage regulator to level out. So now let's see here. Switch over to this. Maybe we'll move a little quicker. Let's check the clamping pulse. And let's see, it's 10, 20, 30. No, about the same. Maybe a little bit more. But yeah, I would say that's not too bad, not too shabby. So let's turn that off. Not too shabby for the power supply here. Not bad. So yeah, I'm a big fan of Astron power supplies. So I hope this at least helped. You know, give you guys some ideas on you know, how well these power supplies work. I mean, I've been buying these things since 1990, and I've got one that's, like I said earlier, I have RS-35M that's been in continuous service for pretty much since 1990, and I'll, you know, service it every once in a while, check the caps, and they appear to be fine. I have had no issues at all, or any reason to suspect that the thing may be failing. Anyway, guys, let me get on out of here, and we'll work on some more videos here. I haven't done any for quite a while. I mean, I got this meter here, this Simpson 260 I'll do a video on. And I got myself one of these BK Precision LCR meters. Nice little meter. And I might do a video on that one too. A really cool instrument. Anyway, guys, hope this helped a little bit. So we will catch you manana down the road, man. See you. Thanks for watching.